In this question on arithmetic series, it looks a bit trickier. We've got lots of algebra going on, but we do know for the first bit, as you can see, I've also written down the equations or the formula on the right hand side. Looking back at the question, we know that the first term is k plus 1, and hopefully it's not too difficult to work out that the common difference is k plus 2. We also know that the final term is 303. So the nth term is 303, and that is equal to a, which is k plus 1, plus n minus 1 times the common difference, which is k plus 2. And we know that that is equal to 303. So let's tidy this up. Expanding out, nk plus 2n minus k minus 2 equals 303. Noticing k's will cancel. 1 take away 2 minus 1 plus nk plus 2n equals 303. So nk plus 2n is equal to 304. Factorising gives us the final step where n is equal to 304 divided by k plus 2. And we have the answer to part A. In part B, we want to show that the sum of the series is given by the following expression. So let's not worry too much about the expression at the moment, but first of all find the sum of the series. So again, we're going to look at using what we know. So for part B, the sum of this expression, the sum of the first n terms, is equal to n over 2, but we know this time that n is actually 304 over k plus 2, and that is n over 2. 2 times the first term, plus n minus 1, so 304 over k plus 2 minus 1 times the common difference, which is k plus 2. So, next step, we need to tidy this up a little bit. Now, from here, we could just go ahead and simplify all of the algebraic terms. However, there may be an easier way. I'm going to start by looking at the formula again. Well, there's 2a, but that's the same as a plus n minus 1 d. Now you might think, how does this help? Well, if we think of this term here, we use this in the first part of the question. Looking back up, first part of the question, we have a plus n minus 1 times d. So they are equivalent, which also means it is equivalent to 303. So that means I can replace this with a plus 303. Now, this is much more manageable. So Sn equals 304 over k plus 2 all over 2, k plus 1 plus 303. Continuing to simplify. Well, 304 divided by 2 is 152 over k plus 2, and inside the bracket we have k plus 304. Now, it is relatively straightforward just to multiply this out, which gives us 152k plus 46,208 all over k plus 2, which is what we were looking for. Now, on to part C. Part C tells us what the sum of the first n terms is. It is 2,568. So, now we can go back down, and we know that 2,568 is equal to 152k plus 46,208 all over k plus 2. Expanding this out, so 2568 times k plus 2 is equal to 152k plus 46,208. Again, expanding this out gives us 2568k plus, and just double checking this, gives us 5136 equals 152k plus 46,208. Subtracting 152k from 2568 gives us 2416, and 46,208 minus 5136 gives us 41,072. Finally, dividing that by 2416 gives us an answer of 17.